This is PreCalc 12, chapter 1.2. This time we're going to be looking at factoring polynomials. And you've already learned how to factor with quadratics, but we need more powerful tools when we're factoring polynomials that are bigger than quadratics. And we're going to start off with the remainder theorem. And we must be dividing by a monic linear binomial. That is, p of x is divided by x minus a. If that's the case, then the remainder is p of a. So let's look at an example. We have p of x equals 2x squared minus x minus 1, and calculate the remainder when dividing by x minus 2. So a equals 2. So p of 2 is 2. We can take that, and we substitute our parameter 2 with brackets, 2 squared, minus bracket 2 minus 1. This becomes more important when we're dealing with negatives. So 2 times 4 is 8, minus 2 minus 1, so that's 5. Okay, let's look at this. We're doing synthetic division. Bring the 2 down. 2 times 2 is 4. 4 minus 1 is 3. 2 times 3 is 6. 6 minus 1 is 5. So we have 5 here, we have 5 here. So just by doing this, we can get the remainder without doing a full division. Now let's factor this. This factors into 2x, x. We need a negative x, so this must be negative 1 and this must be plus 1. So the actual factors are x equals negative 1/2 and 1. Remember, to find the roots from the factors, we go 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2. Okay, you should be able to convert from factors to roots fairly quickly. Okay, so let's try p of 1. That's 2 times 1 minus 1 minus 1. That's 0. Here's where the brackets become important. So 2 times negative 1/2 in brackets squared minus negative 1/2 in brackets minus 1. Now we have 2 times 1/4. That's 1/2. This minus negative 1/2 is plus 1/2, and then we still have the minus 1. 1/2 plus 1/2 minus 1 is 0. Now, if a is a 0 of p, it should be no surprise that the value of p of a is going to be 0. And this is the factor theorem. This is our second tool. X minus a is a factor of p of x if p of a equals 0. And again, this shouldn't be a surprise to you. If we looked at some quadratics that we did last year, these are the roots. If this is p, then p of, we'll call it, if that was a, p of a equals 0. So that's how you can use that to make sense of what we're trying to do. If p of a was here, then x minus a is not a factor. Okay, our third tool. So recall our product factor sum method of factoring quadratic trinomials. The only numbers that we check are factors of a times c. This is our p, right? Product. So the factor property states that if x minus k is a factor of p of x, then k must be a factor of the constant term in p of x. And here's a tip. Once you find a factor, use the factor property for the new quotient. And another tip is try the smallest factors first, then increase in size. So for example, if the constant term is 24, we'll try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Okay, lots of factors in 24. So as an example, we have x to the power 4 plus 2x cubed minus 13x squared minus 14x plus 24. Negative 2 is a factor of 24. So we put negative 2 in here. Negative 2 to the power 4 plus 2 times negative 2 to the power 3 minus 13 times negative 2 to the power of 2 minus 14 times negative 2 plus 24. Evaluate this. Negative 2 to the power of 4 is 16 because this is even, so this is going to be positive. This is odd, so this is going to be negative. So 2 times 2 cubed, that's 16. This is even, so this is positive times a negative. This is going to come out negative. 13 times 4 is 52. And those of you who play cards frequently, there's 13 cards per suit, and there's 4 suits, and there's 52 cards in a deck. Negative 14 times negative 2 is 28, and add 24. So we can add all the positives, add all the negatives, and see what we get. Well, 16 minus 16, that's 0. That's 0. Then we just have to check to see if this is 52. Well, 8 plus 4 is 12. So we carry the 1 plus 2 plus 2, that's 52. Okay, so x plus 2 is a factor. That means x minus a implies that a is equal to negative 2. And we've already had a here. So we put negative 2 here. We do the division. Copy down the coefficients, 1, 2, negative 13, negative 14, 24. Bring down the 1. 1 times negative 2 is negative 2, 0. Negative 2 times 0 is 0. Negative 13 plus 0 is negative 13. Negative 13 times negative 2 is 26. 26 minus 14 is 12. 2 times negative 12 is negative 24. And we better get 0 because that's what we calculated before. And this confirms it. Okay, so our q of x, our quotient, is, so we started with x to the power 4, so this must be x cubed. We don't have an x squared, minus 13x plus 12. So we're looking for factors of 12. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and so on. But I'm just going to use a different number, q of 3. Not starting off with the smallest because I just want to illustrate something here. 3 cubed minus 13, sorry, there's an x there, times 3 plus 12. This equals 27 minus 39 plus 12. Okay, so the positives must be the same as the negatives. 27 plus 12 is 39, and that's 39. So x minus 3 is a factor. We try our division with this. 1, 0, negative 13, 12. And we're dividing by 3. Bring down the 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 13 plus 9 is negative 4. Draw our dotted line. 3 times negative 4 is negative 12, and that's 0. Since this is x cubed, this must be x squared. Our next polynomial is x squared plus 3x minus 4. And this is a quadratic, so we can factor normally using our quadratic rules. X, X. So one must be positive, one must be negative. It can't be 2. So it must be a 4 and a 1. And this is positive 3, so this must be positive, and this one's negative. So fully factored, P of X equals, our first factor is X plus 2, X minus 3, and X plus 4, and X minus 1. So I've known the factors, so that makes it easy to illustrate. But what happens if you don't know the factors? If, for example, we tried a equals -1 and a equals -3, we would have got a negative number here. We would have got a positive number here. And there's no way to get from negative to positive without going through 0, because all polynomials are what we call continuous functions. That means we can't lift the pen from one spot, jump to another spot, and continue drawing. So there has to be a number between -3 and 1 that makes P of X 0. And we saw that at -2. Okay, so we'll write that out. Because polynomials are continuous. And if you're taking calculus, you'll learn this in calculus. Okay, backwards problem. What is the value of k that will result in 2x to the power 4 plus kx cubed plus kx squared minus 8 divided by x plus 3 will have a remainder of 10? So x minus 3 means that a equals 3. P of a equals P of 3 equals 2 times 3 to the power of 4 plus k, we substitute 3 to the power of 3 plus k, 3 squared minus 8. We want this equal to 10. Okay, so let's just break this up here. 3 to the power of 4 is 81. 2 times 81 is 162. 2 to the power of 3 is 27, so 27k. 3 to the power of 2 is 9, so that's 9k. Minus 8 equals 10. Okay, so we have 27 plus 9, that's 36k. 162 minus 8 is 154, and 10 minus 154 is negative 144. So k equals negative 4. And you just divide that out. So tips. If you're given values, it's best to substitute and see where an answer might come out. And in math, there's always 3 main tools that we use: algebra, substitution, and factoring. These are the factor tools that we've learned: factor property, factor theorem, and the remainder theorem. And that completes this lesson.